Morning, everyone. I hope you're just as excited as I am to talk about some monitoring, logging, dashboards, alerts, getting called out of bed at 4 a.m., that kind of stuff. And the next 50 minutes or so, I will try to share with you how you can ensure that you get called out of bed, but only when it's really necessary. So in case you're wondering, who the heck is that blonde guy up there? My name is Henry. Hi. I'm from the Netherlands, and actually from an island within the Netherlands, the island of Texel. It's one of the Waddeneilanden that go from the Netherlands to Germany to Denmark. I've been living there for 6 years now. I've been working there for 5 years with Azure technology. And since a year and a half, I'm an independent architect and developer. Right now, I work at a bank at ING, and I also do a consultancy job at another client within the Netherlands. And all the things I do that are Azure and Azure DevOps. If you ever have any questions afterwards, criticism, questions, want to have a chat, feel free to reach out on LinkedIn or Twitter. I will also be at the conference for a couple more hours today and also tomorrow. And without further ado, let's talk about logging and monitoring. Welcome. So I have given quite some thought about how to structure this talk, and I came up with 3 parts. Which I named the very boring part, the pretty boring part, and then the maybe boring part. So I talked that over with my wife, my better half, and she said, well, Henry, you're always so negative. What about this? You start with the amazing part, and the really amazing part, and then the mind-blowing part. And then I talked to a developer, and he said, it doesn't tell me jack poo. Let's just give these 3 topics. We're going to start with a little bit of theory about monitoring and logging. Then we're going to be talking about what to monitor about your applications. And finally, I will give you a few demos on how you can do that on Azure, which is my cloud of choice. So monitoring. The essence that I hope I can convey to you today is that monitoring is the art of knowing what will be happening in production. If you are working at a company that really cares about security, a bank, for example, you will probably find yourself in a situation that you will not have access to your production resources. You cannot log into the Azure portal and see what's going on. You cannot connect to a database to see what's going on. So you have to take other measures to start knowing what will be happening in production, and especially how your users are faring there. Are they happy using your application or not? So when it comes to monitoring, there are 3 topics that I want to introduce to you. The first one is instrumentation. This is the art of getting numbers out of your application. And it's actually the one I think that is most forgotten out of the 3 that I will introduce. So a sample of a metric is, for example, the temperature. It's a thing that we can record at a steady interval. So the temperature in this room, I don't know, something around 20 degrees. It feels like 23 for me, feels like 19 for you, but it is actually 20, I think. And we can record that every second, and then we're starting to record a metric. And you can probably see that we can use these metrics to start creating graphs. And combining graphs gives us a dashboard. And then we draw a horizontal line on a graph, and we get a notification whenever something goes below or above that line, we have an alert. So that's how we work with metrics in our application. Now, it's important to know that there are 2 types of metrics, events and values. For example, a value is the temperature, and an event would be just somebody walking in the room at a certain time. Another thing that's interesting about metrics is that we can give them dimensions. For example, instead of having 3 metrics, temperature room 1, temperature room 2, temperature room 3, we can have 1 metric, temperature, with a dimension which is called room. And then we can start recording 3 values for that metric at every point in time instead of 1. Doing it this way, instead of having separate metrics, allows us to quickly get the average temperature in the whole building or zoom in on a particular room. How would you use it in an application? Well, for example, a metric like user ID or account ID is really helpful to see if your system is behaving differently for one user than for the other. What's also good to know is that this will generate a lot of data. If you start recording, I don't know, the CPU usage percentage every second, that will generate a lot of data. So what we do with this data is that we roll it up over time. We make it more fake. We start recording it every second, but for all the values more than a week old, we remove these 60 values and we collapse them into one for the minute. That way we have really detailed and precise information of something that is happening right now or just has happened, so we have really good insight into our system, how our system is working. But in a week, it's not really interesting anymore to know per second how the CPU is faring. But it might be interesting to know it per minute or per hour to start identifying trends in usage over time. The second thing that I want to introduce to you is tracing or trace logging. And I think this is what we as developers are probably most familiar with. We put a lot of statements in our code emitting text messages to tell us what is happening in the execution. This is really code oriented. This is trying to emit at what place in the code the application was executing at a certain point in time, which parameters it had maybe, and a descriptive message. Now, of course, this can be a source of metrics again, because the number of log entries per second can be an interesting metric, especially the number of warnings, the number of errors. And it's good to know that this is often retained for a limited amount of time. The amount of data this generates is even more than the data for instrumentation. And it's probably not economic to keep all your logging for forever and ever and ever when it comes to trace logging. Because this doesn't hold for another type of logging, which is called audit logging, or just logging, according to some theory. This is the art of recording all the important state changes in the system. Things like, at 5:45 we delivered 545 pizzas to my doorstep. Henry paid bill 123. Henry ordered this book. These are important events to record to later on explore why certain choices have been made or why things have happened. So I, for one, would like to know why I would get 445 pizzas, because I don't eat pizza. So this is much more concerned by the user. What is the user doing and how is the system, has the system decided to react on that? Now this you probably want to retain for forever and ever, especially when you find out that you have been hacked a while back. You want to find out what that hacker has done in your system. Now, for all these three, we will start exploring how to work with them. Now that we know which types of metrics and logs we want to emit, let's explore the architecture that we will need to do so. So let's assume we have an application instance. This can be a function, an Azure function. This can be code in an ASP.NET application. It can be, I don't know, Java running on some AWS thing that I don't know. The thing is, it has to run on something. So that used to be a virtual machine. Now it might be a container, or it might even be a serverless application host if you're into that, like me. Now, to start measuring about this thing, we're going to do two things. We're going to add an agent to the platform that we're running on to start collecting metrics and logs of everything except our own application code. Something about, I don't know, network traffic, CPU usage, memory pressure, IOPS, all these kinds of fancy things. And in our own code, we're going to install an SDK that allows us to start emitting logs and metrics from our own application. So, and these two things combined can tell us about the state of our system. Now, in the past, metrics and logs recorded were often saved on the disk of the system where it was running, and when somebody needed it, it would be retrieved. That's all good and well, but if your VMs are like popping up and down whenever you need them, or containers even worse, and serverless you don't even care about the service, that doesn't work anymore. So what we nowadays do a lot is we submit all this stuff to an HTTP endpoint. And from there on, there will two things be happening. All the logging will be saved in a database. Now, this is not your typical SQL database. These are often data stores that are optimized for storing humongous amounts of data. It can be just CSV if you like to, but in Azure we have a specific database offering, which is Application Insights that does this. Now once all the data is collected there, you can of course start querying it. And the same we do with a time series database, where we store all our recorded metrics. A time series database is completely different from a regular database, since it is optimized for storing time series values. Point in time, value, point in time, value, etc., etc. Often they also have this built-in behavior of rolling up values recorded over time. It's part of the database engine. And often they even have a built-in capability to, I don't know, forget everything that's more than a year old. They're append only, etc. They're really optimized for this scenario. Now, on top of this database, we can run a visualization engine, and then we start creating dashboards on top of that. Of course, we can query the metrics in the time series database as well, but nobody really wants to look at the long table of values. So we start using graphs there. This is what we call the so-called cold path. This is about storing it and querying when we need it. Next to this, we can also add what we call the hot path. Instead of storing all the data that comes in and querying when we need it, we're going to write the query up front and then let all the data flow in front of the query. And whenever a record comes through that the query thinks it needs to answer the question that it's responsible for, it picks up that record and keeps it for a while. And whenever it finds an answer to its query, either a yes or a no or a record that matches, it will say, hey, there is a new result. And all the data is not stored in the query engine. It's dropped right after. Now this we can start using for creating alerts. If I want to know if a certain metric goes above 80%, I can define an alert, a query, and that query will see all the data, and whenever it thinks, yep, it's above 80%, it will start shouting. Nowadays, we can also do the same thing for logging data. So we can see all the logs streaming in and configure alerts on those as well. So for example, whenever a critical log entry is emitted by the application, we can have an automated alert notifying us about it. And at this point you might be wondering, we're developers, at least I hope you're developers, because it's developers conference as far as I know. And you might be wondering, why would I care about all this stuff? I find that this is for operations, not for me as a developer. Well, there are reasons for you to care, I think. First of all, DevOps is hip, DevOps is cool, which might mean that you as a developer have to do everything. You have to be a developer and an operator in one, and you're assuming what we call a no-ops approach. You do everything yourself. Well, then you definitely need to need this stuff. If this works for you, well, you go and find out. There are a lot of pros and a lot of cons. But what DevOps started out as is a philosophy that we have to start removing the separation of developers and operators. We start to unite and focus on common goals of delivering business value to our end users. And one of the things you need to do for collaboration is talking to each other. And to be able to talk to each other, you need to know at least a little bit about what the other guy is doing, or girl. So, hence, I think you should learn about monitoring and logging as well. Another thing is, like I said, we have this platform that we collect metrics and logs from, and from application code. If you, as a developer, do not emit logs or metrics from your application code, there is nothing to monitor about your application. People can only monitor the infrastructure that your application is running on. And hopefully, after the next 10 minutes, you will agree with me that that's not always useful necessarily. So, I'm going to assume you all care. And if not, well, too bad. So, you might be wondering, cool, we care, we know a bit about the architecture, we know what we want to emit. What do we start monitoring then once we're emitting? And I think the best way to answer that question is by turning it around. So let's take, and this is the best joke that's going to be in there. So what do you not monitor? Because that's the thing that I have learned over the last couple of years and that I wanted to share with you. So the first thing I think you should be critical about is monitoring just a system that your application is running on, your infrastructure. Do your users really care about the percentage of disk space used? Do you think that your manager really cares if you use 65 or 67% of the CPU time? I don't think so. So maybe you should focus less on how your systems are doing and more on the user experience and try to monitor that. Another thing I think you should try to avoid, where possible, or at least be critical about, is averages. They're lying, cheating bastards. If I have two values and they're really far apart, they might both be terrible, but the average might look awesome. I think average income It might look great for some countries, but if you start diving into that, you might find the situation is not as healthy as you were hoping. So to get about that, you can, for example, start using dimensions. A temperature average of 20 degrees over 3 rooms might look fine, but if it's 10, 10, 30, 10, 10, 40, that's maybe not as a healthy situation as you thought. And another thing you can do is, instead of looking at the averages in the same graph, also plot, for example, the minimum and the maximum value, or the 5 percentile and the 95 percentile graph. To add a little bit of nuance to that, of course, collecting system metrics and averages can be helpful. They are a great way for really quickly gaining insight into how stuff is running, more or less. And system metrics can be great leading indicators of what is going to happen in a couple of days. If your disk space is that's free, that's like 5%, and the next day it's 4%, next day it's 3%. Well, we all know what will happen in 3 days. So they are valuable, but not necessarily the whole package. To explore that thought, I've worked at a company that had 1 or 2 databases. Well, actually we had 60,000. And for all of these databases, we recorded the percentage of database capacity in use. And it was always somewhere between 10 and 20%. And all of a sudden, this graph came up. This is based on a real-world scenario. The numbers are fake, by the way. And one of the operators came running to me and he said, "We have to scale up the database." And I said, "Why?" He said, "Well, it's at 100% capacity." So I said, "Cool, we're finally using what we're paying for." True story. And then he said, "Yeah, but the user is not satisfied because he cannot do the query he needs." And then I can be a bit of a jerk. I said, "That's an assumption." So what we did, we called the customer, and he said, "Yeah, sure, everything's perfectly fine. I'm running this really heavy report that I know that will take a couple of minutes, and that's fine because it allows me to grab a cup of coffee." So my theory is that whenever that user feels like a cup of coffee, he runs that report. So for me, that also means that if we make this query run faster, he can no longer get coffee. So I think our user will be less satisfied if we scale up the database, and we'll lose money in the process. So that's the thing that I wanted to point out. Just focusing on the systems is not always helpful. It's not always bad as well. So there was the proposed alert, and in the end we didn't install it. We didn't spend money and everybody was happy. Another case. This is the average response time of an API. Here we're trying to measure some user experience by measuring average response time. And the question again is my user happy? Well, 100 milliseconds, I think, 120 maybe, is a bit much. But I think this was running WCF instead of Web API, so it's not too bad. You might think. But if I explode this graph by using dimensions, I get this picture. So what happened here? I added the dimension, which is called operation name. And I am recording the time now, the average time needed for adding an item to the basket, for checkout, which is the orange line, and I'm measuring the average time for viewing an item in my web shop. From this graph, I feel like we have an issue. Like the time needed to add an item to the basket is way too low, way too high. It's well over 500 milliseconds, over a second even in some cases. We might be actually losing money here. So the average was a bit of a lying bastard, but dimensions helped a little bit maybe. So the point I wanted to stress here, especially for response times, etc., is start using percentiles. Now I'm not going to be chanting percentiles, percentiles, percentiles. Yeah, sorry. But I think percentiles can really help you out trying to act too much on averages. The bad thing is that in the demos that you will see later on, I'm not using it because it's not yet supported, built in by the Azure platform. So the point I try to make is measure things the user cares about and think it through, because it might not be as easy as you think to find that really good metric that the user cares about. And I thought, to avoid death by PowerPoint, let's take a really quick look at a dashboard that I've created in Azure. And I will show you in a bit how you can create this as well. And this dashboard shows a number of metrics about a system that I've created and displays them. Now, I'm really sorry about this really big peak. That should not be part of the demo. It was running fine continuously for 4 weeks. And when I opened this up this morning, that peak was there. The thing that I want to point your attention to is on the top right, it's the average queue delay. What this application does whenever a command comes in, it doesn't execute it, it puts it on the queue, and a worker picks it up and does the actual work, a common cloud pattern. Now here we want to monitor if everything is well. So the operator came by and said, I put it in the monitoring. And he started collecting first the average number of messages on the queue, which is a thing I think we all do quite often. But it doesn't really record the user experience. Because if I have 10,000 messages on the queue, but I'm processing 10,000 a second, I have a second delay. Might be cool. If I have 4 messages on the queue, and I do only 1 per second, I'm going to have a 4-second delay. So instead of focusing on the message on the queue, it might be better to start focusing on the average delay between queuing a message and processing the work. Now that would show this perfectly acceptable graph of roughly 1.5 seconds over time. However, I added another graph to the right that shows the maximum queue delay. And if I zoom in here and try to remove this annoying peak, you will see that the average time looks pretty cool, but the maximum delay is really, really bad. Now I know why. I added an experiment of an exponential delay over a random, so this creates really weird spikes. But you can only find it looking at the maximum response time of processing time. Just a simple example. Now, a number of these things that I've learned over the last couple of years shouldn't have taken so long, because there is a pretty good book. It's called Practical Monitoring. It's written by Mike Julian, and he goes over a lot of these things as well. And the point he makes as well is measure the user experience. So I can recommend this. It's not too expensive. For those who don't like reading, it's also quite thin. And that's like, I hope, the boring stuff. What I will do next is just walk through how I do all these things in Azure and hopefully inspire you to do something similar at home and try to experiment with it. But just a little bit before we go to the demo, I want to tell you a little bit about the application that I'm going to use for the demo. So it's going to be a URL shortener, and it has one HTTP endpoint that we can either do a post to, then we provide an alias and a URL, creates a message, goes on the queue, goes to another function that will process the message, update the database, and also a Redis cache. And if I do a get to the same endpoint and I specify an alias, I will get a redirect to a URL. With that said, let's take a look at the demo. But are there any questions before I move on? Who's still awake? Well over half. Okay. The pressure is on. So, like I said, there are 2 types of metrics and logs recorded. Those that's from the infrastructure that I run on, and those from my application. So let's start with the infrastructure that I run on. And one of the things that I run on is a SQL database. So I go to the Azure portal and open up that resource, and the first thing that shows up there is a graph. Yay! This is a graph of a metric that Microsoft is automatically recording for me. So for all the managed services in Azure, metrics are recorded automatically. Now what we see here is the percentage of compute capacity used by the database. But I am going to need more. So what I do, I search for metrics in the resource menu, and then a new view will pop up where I get a canvas where I can start creating my own graphs. Now to do that, I have to add 1 or more lines to graphs. And that's what I do at the top here. And I have to make 4 selections for a line to appear. The first one is the resource. Now since I am navigating to this canvas from a resource, it's pre-selected. Next I have to select the metrics namespace. Now, there's always one namespace for each resource type, except for application insights, which we will see later on. And then I can select the metric that I want to graph. And as you can see, there are quite a few recorded by Microsoft automatically. So let's pick one, I don't know, blocked by firewall. Oh, that's interesting. Who's that? Not somebody in the room, I hope. So now I get this line for the number of connections blocked by the firewall, which is just 1 in the last 24 hours. What if I want to correlate this with, I don't know, the amount of CPU used? I can just add a line like this. And I can add more metrics the same way if I like to. I can add as many as I want. Well, I've never tried more than 10, but I assume you can add as many as you want. Now, having graphs like this and building them on the fly is really cool, but it will be much handier if you could create a dashboard with multiple graphs attached to it. So what you can do here on the top right is you can go to Pin to Dashboard, and there are two options. You can either add it to the current dashboard, or you can pick a dashboard from a list, and from here you can also create a new one on the fly. So let's do that. And that should take only a second. And there we go. And I've created my first dashboard in Azure. By the way, this is a new thing in Azure, that every time you open a new tab or navigate somewhere that you have to relog in. So I hope that goes away quickly. I have my dashboard. Yay. Now I can start adding more graphs from here. Another thing that I can do is I can do all the things that you would like to do. So I can make things larger, I can make things smaller, I can remove them again. Let's say I'm done and I say I want to start. That's not what I wanted, sorry. Customize tile data. I can say, well, the default for the dashboard is show the last 24 hours. But what if I want this not to be in UTC, but in local time, and I want to show the last 7 days? There we go. So I can start building dashboards like this. Now, this gives me a lot of insight in how my application is faring when I get to this dashboard. But I'm not constantly looking at the dashboard at 4 a.m. So what if I want to get notified whenever the average CPU used goes above 12%? Sounds like a real world scenario to me. So I click on the graph again. It opens up in the canvas. Now instead of pinning it to the dashboard, I go to New Alert Rule. Now in here I get a pretty elaborate interface that allows me to define an alert. First of all, I have to select the resource that I want to alert on. Then I have to select the condition under which I want to alert. So let's open up one. This is about the database firewall rule, so let's remove that. And then open this one, which is about the CPU percentage. This is automatically created because on the graph, these were the two lines that I shown. And now I can start creating a condition. So something was added, I don't care. And I'm going to say I'm going to create a static alert, which will go off whenever the average is greater than 12. And I can specify how often I want to evaluate that condition and over which period of time. So on the right, we can see the frequency evaluation is every minute, which means that every minute my query is going to produce a result, and it's going to look back 1 minute to calculate the average. So this has the risk of giving an alert and closing it a minute later, and then 5 minutes later giving it, and then 6 minutes later closing it. So maybe I do not want to get called every couple of minutes, so let's take the average over the last 5 minutes. So now the average will be smoothed out over a longer period of time, and I will get fewer alerts, and the risk of an alert turning on and off on its own is smaller. The third thing I have to do is to select an action group. So let's say I want to call the CEO out of bed whenever I want to start, whenever I detect a condition. I can put in his cell phone number for alert number 1, alert number 2, alert number 3, but then, he gets called a lot and he changes his cell number. So I do not want to go back to all these alerts and change it to his new cell number. Now I want to create action groups that I can reuse for all the alerts. Now I have already created one, so let's pick that and continue. Then I have to give the alert a name and a description, and that's all there is to do. I'm not going to enable it, because then probably I will get called out of bed quite often. So this is how I start using the metrics embedded by the Azure platform. Now let's switch our attention to metrics that I start emitting for my own application, unless there are any questions at this point. Anyone? Yes?
How much time does it take for dashboard to reflect the current status of the resource?
There is, so the question is, how long does it take for the dashboard to reflect the actual state of the resource? The old metric system, alert system that's currently being phased out of Azure, it took minutes. And in my own experience right now, it's within the minute. But I do not know the strict SLA top of mind. Anything else? Okay. Then let's switch our attention to starting emittings for my own application. So what I need to do that is, first of all, create an application insights namespace in Azure. That's just another click. I will show in a bit. And then I have to install the SDK in my application. Now for a C# or any .NET application, that's just a NuGet package that you need to install. It's called Microsoft.Application Insights. And once you've done that, if you are using the built-in dependency injection for the new .NET Core ASP style, you only have to call services.add-application-insights telemetry, and your application is ready to start collecting log entries and metrics. Now, to actually start emitting them from the application, you have to do two things. For telemetry or metrics, you have to inject a class called telemetry client. It's part of that NuGet package. To start emitting logs, you can use the built-in iLogger interface that's part of ASP.NET Core. You can get them both from the dependency injection, then you can start using them. So let's quickly satisfy my OCD. For emitting a metric, I use the telemetry client, and I call into a method called getMetric, which gives me a reference to a metric. I just specify the name of the metric, and then the name of one or more dimensions, if I want to use dimensions. And then I call into track value to actually record the value. So the value has to be either an integer or a double, and I have to specify a name for the dimension. That's it. If I want to emit log entries, I go to the logger interface and I call, for example in this case, log information. And now my application is emitting log entries, it's emitting metrics. The application insights SDK is configured to pick them up and to forward them to the application insights workspace in Azure. So switching back to Azure and going to application insights. First of all, to create a new namespace, that's just putting in a name. So let's not wait for the, oh, there it is already. It's just putting in a name, and you can specify where you want it to be located. I already created one up front. So what we see here is a number of default graphs generated. But if I go to metrics now, and I start creating a graph, you can see that there are multiple metric namespaces. And there's also one called Azure.Application Insights. And this will hold all my custom metrics. This should hold all my custom metrics. Please, Internet. So all the demos yesterday for the meetup went perfectly fine. So I think this is like retribution. Yeah, there we go. So this is, for example, one of the metrics that I'm emitting. The average delay for adding an alias. And from here on, I can work with this graph just as with built-in metrics. Switching to the logs, one of the things that I can do is go to logs and then analytics. And this will open up a specific type of database, which is really, really comparable to Azure Data Explorer, for those who know it. And once I'm in here, I can just start querying my logs. For example, so the logs are in a table called traces. And here I can say, I want to order them by timestamp descending, and then I get them. So this will take a couple of seconds. You might think, that's slow. But if I start executing this for the second time, we'll hopefully see that I get the results back in less than a second, and probably in less than a second, of 10th of a second or 100th of a second. So it took 13 seconds right now. So let's execute that query again. And unfortunately, I overpromise it. That's not cool. There we go. So I still want to show you how powerful this engine is. So let me execute a count over all the entries. There we go. Half a second to count 1.4 million rows. And you can expect this performance to be kinda constant, even if your data amount increases. So now I can also do things like where a message contains, I don't know, add. And I will pretty quickly get all the log entries that match this query. And I think this is really cool. However, the coolness doesn't stop here. Another thing that I can do is go to a thing called search. And if I go here, I cannot search only my log entries. I can search all my requests, all my dependency calls, and a lot more. Actually 7 things are listed here. Page views, custom events, everything that's collected by Application Insights I can search here. And the cool thing is that it all gets related back to a request. So what I can do is I can retrieve the timeline of a request. So for example, somebody calls into /home/pages, and I get a timeline saying, okay, the request came in, then you emitted these 3 traces, and then you called into the database, that took so long, then you returned, then you emitted these traces. Finally, there we go. So here I get all the results over the last 24 hours. And what I can do is I can trim this list down, for example, to only requests. And once I have that line, I open one up. And here I see a breakdown of the timeline of my request. So all the things that are happening. And if I rather have a list, I can get that as well. This is all stuff that Application Insights provides you out of the box once you've hooked your application up. Now, one final thing that I promised is that it's also possible to start creating alerts out of log entries. So to do that, let's take a different route and go to the Azure Monitor. Azure Monitor is a resource that is responsible for managing all the alerts that you create within your subscription. So if we go to alerts, we can see first a list of most recent alerts. That's empty. But to quickly show you how that works, let's go to a subscription for which I know there have been alerts in the past. And then I can create a cool list of all the alerts that have opened. I can open it up, see the details, see the status, see when it opened, etc. So this is all kept here. So if you're a small company, you do not have your own implementation of a ticket and alerting management system, the Azure portal might just be good enough for you to start doing it. What I wanted to show here is if I want to create a new alert rule from here, I have to start by selecting the resource. So let's go to the correct subscription, and then I'm really sorry for the internet connection. I tested this beforehand and it worked perfectly fine. And I am going to alert on an Application Insights instance, namely this one. And once I've selected the resource, I can start selecting the condition on which to alert. Now here, before I pick, the first time I picked a metric because I was navigating from a graph. But now I first have to select the type of alert. That can either be a metric or a log search or an activity log. So let's now pick log search and I do custom log search. And here I can start creating a query just like I did before. So I do traces. Then I don't know where severity level is larger than 4. So now I'm querying for all my critical alerts. And I can start creating a rule just like before. And now I will get notified whenever a critical log entry comes in. This is all that I wanted to show about how to do it in Azure. There's just one thing that I want to step back to a little bit, and that's one of the downsides of Application Insights, or actually a couple of them. First of all, it uses sampling, which means that when you start emitting mass amounts of data, not everything will be sent to Application Insights. It will sample, for example, 20% or 50%. You can configure this, and it helps with keeping the cost down. That's awesome. The disadvantage is that you also want to do audit logging this way, that you're going to miss entries, and that's not good. Another thing is that once you emitted a log entry or a metric, it will take 5 minutes roughly for it to show up in the portal. So this is for the custom stuff. And that is because Application Insights ingests it into its databases in blocks. That's not really cool when you're running a complex application locally and you want to quickly drill into the logs. So one of the things that I often do in my applications, instead of hooking up Application Insights directly, is I hook another log system to the iLogger interface, and then I put Application Insights behind that intermediate package. So for example, let's take nlog. I know that Serialog is winning the war, but I'm still using nlog. So I put up nlog to listen to the iLogger interface, and then when I'm running locally, I'm not going to forward to Application Insights, but I'm going to forward to a local file, or for example sec, which is a really, really simple system that can also collect log entries and makes them really searchable quickly. And to do that, I thought I'd quickly show you how I do that. So this is dependency injection configuration for an Azure service. It does a number of things that you would expect, and it also sets up my logging and my monitoring. Now for the logging, what I do is I start creating an nlog interface configuration, and nlog works by defining multiple targets. So I create an Application Insights target, and I create a sec target. And based on configuration, I'm going to switch between the two of them. But you don't necessarily have to switch. You can also do both. So what you, for example, can do is you can submit all your audit logs to Application Insights with no sampling, and all your trace logs to Application Insights with sampling. This is all the setup that is needed for using nlog. That's really everything I wanted to show you. So switching back to PowerPoint, I hope you have seen all the components of this architecture that I drew up at the start. And there are two more things that I wanted to share with you. The first one is that the demo that I showed you, the tour of the configuration, the dashboards, etc., and the running application that generated the data, you can get it from GitHub. It's on github.com/henrybeen. And there is a C#.NET solution that you can download to your local computer. It contains an ARM template. You publish that. Once that is done, you publish your application code to the app service that's created, and it will be a continuously running demo. It will reset itself every 4 hours, and you can then experiment with creating graphs and dashboards with non-production data. And the second thing is, especially for the people who I met yesterday on the meetup as well, dashboards and alerts and action groups, they're all Azure resources, just like any Azure resource. Which means that you can manage them through infrastructure as code, through ARM templates. So if you are already using ARM templates to create your infrastructure, you can now also set up your monitoring and reporting infrastructure using ARM templates, which is really cool because once you've done it for production, it will automatically be available in your test and acceptance environments as well. Are there any questions? Nobody? Well, in that case, thank you for your time. Please do try this at home. If you have any questions, feel free to find me. I will be here for a couple more hours and tomorrow as well. Thank you.